Hello, everyone. I'm sure you're sick of seeing me, probably. Um, Welcome to the session. My name is Mark Bolinsky. I'm a Senior Technology Architect here at InterSystems. Today, we'll be diving into all of InterSystems Cloud technology. Think of this session as a primer or an infomercial for each of the different technologies, all in a single place. I'll have a slide at the end of the presentation which provides a schedule of all the individual topics as a quick reference. So let's jump into it with a quick overview and background. Here at InterSystems, we have three main cloud strategy. We have native, open, and the marketplace. We will discuss each of these in a little more detail. We now have support for a declarative system configuration, and specifically, maybe not so much an opinionated deployment, but something that'll help with automation, because I don't think we're truly opinionated yet, but it'll help with integrating into things such as Ansible, Chef, Puppet, any other cloud provisioning tools, cloud formation, so on and so forth. We now provide structured logging, which isn't necessarily cloud specific, but very common and useful for large federated, sharded configurations to have a consolidated or a centralized logging and ease of integration with third-party log server tools such as LogServer, syslog, FluentD, or Splunk. We now have a non-root container is now available as of 2019.3 and above. This will certainly make system and security admins very happy. We'll discuss this, what this actually means for IRIS itself. And last and certainly not least, and possibly one of my favorites, is SAM. This is our new centralized system and alerting and monitoring solution built using industry standards and practices and data formats. Throughout the session, if you have questions, let me know. I'll throw a microphone at you to make sure we can get the question recorded. But anytime, feel free to ask questions. As mentioned before, we have three different cloud strategies: native, the open, and the marketplace. Let's quickly compare the difference between native and open for the time being. Native is where we initially launched our cloud strategy with the introduction of the InterSystems Cloud Manager, or ICM for short. ICM is great. If you aren't using some other cloud provisioning or orchestration tool, you want to do something quick, either locally on your laptop, if you have Docker already installed, or you want to play around provisioning something out in Amazon or Google, Azure, whatever. The interface to using ICM is very simple, leveraging JSON files for its driven parameters. The provisioning of resources is what we called, or what we consider effective placement, meaning one container or instance per deployed node, with the assumption that the container node will require all the resources that's provisioned to it. ICM doesn't do like a multi-container deployment for a single instance. You could probably fudge it and massage it a little bit to make it do that, but out of the box, it's not. And going back to something I've said many times, and I believe, is containers does not equal cloud, and cloud does not equal containers. And so ICM not only has built-in support for the various cloud providers, ICM also has VMware vSphere and bare metal support, along with either container or what we call a containerless deployment model. So it's completely your choice. And that's what we would consider our native. Now, the open strategy is leveraging Kubernetes for your complete orchestration needs, including deployment, scaling, management, etc. The provisioning of Kubernetes is kind of on your own, meaning you can either leverage one of the managed Kubernetes services from the cloud providers, for example, GKE on Google, EKS on AWS, AKS on Azure. And there's a lot of value in doing that because you don't actually have to worry or care about all the components that make up a Kubernetes deployment, the etcd database, your control nodes, blah, 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 blah. It's all done for you. You can certainly do that if you want to. Or you can choose to deploy Kubernetes either on-prem, on your own hardware, or within just virtual machines or instances deployed out to one of the cloud providers. There are third-party tools that help facilitate this, such as Rancher's RKE, Google's own KubeADM, and so on. And from personal experience, I've stood up a Kubernetes cluster in-house. It was challenging, but it was certainly well worth the effort from the learning experience based off it. Because you certainly learn more about Kubernetes operation than just trusting the managed service of just dropping it out there and hoping it just runs. Usually does, but knowing the underneath mechanics is certainly beneficial. Third cloud strategy is the marketplace. So you heard Terry and Scott this morning mention that you have the ability to just buy it and pay the cloud providers, Amazon and Azure, directly. You don't have to talk to us. You don't have to look at us. You don't. Billing's all done through them. And this is also for IRIS for Health as well. I believe we're working on Google here soon as well. I'm not 100% sure if that's released. I'll certainly stay tuned for that. And of course, we also support running IRIS and any of the other, these other shown cloud providers, Tencent, AliCloud, VirtuStream, and even VMware Cloud. Hopefully that comes through okay. So let's take a look at an example using the native approach. Here I have one of the example architectures from an article I wrote out on the developers community using GCP or Google Compute. This example deploys a production-grade sharded cluster with 4 nodes plus their mirror pair. Each mirror member is split between zones for a best practice approach for HA to protect from a zone failure, and a third zone for the arbiter or the ICM server. You don't necessarily need to put your ICM provisioning server or the arbiter in a third zone because it does add cost, but if you have a third zone already provisioned or in use for something else, it's good to put it there. If not, I would put them in with one of the other 2 zones. To deploy that using ICM, here we have the simple ICM defaults.json and the definitions.json file. A couple things to note about each of these files. The defaults is primarily kept very simple. And it mostly contains your cloud subscription details, anything else you want to have standard across all the deployed instance when you invoke ICM. So anything you want consistent across all of them, they would go in this defaults file. The definition file is where you provide the details for each deployed IRIS instance. So with just a few lines of JSON code, ICM enables you to quickly deploy an entire 4-node sharded cluster of any cloud providers that are supported by ICM. Any questions on defaults versus? Oh. Here we go. Come on down.
What do you mean by sharded cluster?
Our sharded clustering, I'll take that back off you. Our sharded clustering is a new feature that came available in IRIS, is it 2018.1? Where it allows you to scale your data horizontally. Instead of having one database instance, you can have a number of database instances, and it still looks like one logical representation of your data. So you can write queries against the sharded cluster, and it will return results from across all of them with a single SQL invocation. Sure. One area I've been clamoring for is the declarative system configuration. I'm probably sure, like many of you, would be pulling your hair out, really wanting to leverage some automation tools. Ansible, I'm partial to Ansible. I like Ansible. Chef, Puppet, name your thing, vRealize, whatever. The configuration state file, or the CSF, gets us there. So in the age of automated provisioning, having a declarative deployment, not so much opinionated, that's a different thing in kind of a loaded term. But trying to adhere to standard cloud practices, such as the 12-factor app principle, tells us that the configuration should be held within the environment. With CSF, you can easily give your container or IRIS instance the identity and configuration that it needs to be in its final state. Instead of running a generic installer and then jumping all around from a UI and executing setup commands and APIs and manually adding configuration files after the installation is complete, who wants to do that? It's a waste of time, really, for something that's actually very predictable as well. So now how we accomplish this is with the ISC CPF merge file environment variable declaration, which points to the path of the declarative configuration state file, or the CSF file. The CSF follows current CPF parameters. So mostly everyone familiar with the iris.cpf file? Yes, no, don't know, don't care. So the CPF file, for the most part, it's just a straight ASCII text file that contains a lot of configuration parameters. We provide a stub default one, but what's great about the CSF, not to be confused with the CPF, you can influence and override those default values. So with 2019.4 of IRIS, it will support all available parameters, including mirroring, including sharding, that you can manipulate all of this. There's a detailed session covering CSF, so I don't want to take too much thunder away from their session. So be sure to catch that session for more details. And I'm just touching on the highlights here, but this is one of my favorite ones because I've been dying to have this. But for starters, let's take a quick look at the usage. Does that come across okay? So on the left, we have the default CPF file. Contains what normally does. This is an out-of-the-box iris.cpf file today. It's the usual default configuration file. On the right is the CSF file, and it only includes the parameters you want to change from the default values. Next example, I wanted to enable ECP, enable sharding, and change some memory settings. But I could have also added in different paths for primary and alternate journal file locations, databases, write image journal file locations, and so on. Increased journal buffers, whatever. What happens on startup or the container initialization is the startup will merge the contents of the CSF file on the right to that within the CPF file. And then that becomes persistent for that configuration. And that will be the final state of the configuration after the startup. So no more having to jump around and set parameters to your preferences after the install. You can declare it once and be done. The other benefit to using CSF is to also enforce configuration compliance with your desired standards. And this helps a lot with the security control front. Security auditors like this that ask for how do you ensure compliance, configuration compliance. So this helps with getting that. So if someone should happen to go in, manually hack up something, change some parameters, and things got weird, you can re-invoke or reinstantiate the CSF file. It gets you back to a known good state that you know works for your configuration. So it's a way of forcing compliance. Any questions on CSF?
Is that protected during upgrades?
Yes, the question was, is that protected during upgrades? Yes, it is. Moving on to structured logging. There's tremendous benefit to having structured logging, which can now easily be consumed by numerous standard industry tools and consolidated for centralized logging, searching, auditing, security, compliance, and so on. Here's a new example of the new logging format. In this example, we see each log entry now follows standard structure of the when, the what PID, security level, event type, and text. The new structured logging is totally open and dependent on your client for output. You can set up the internal service to serve CSV, JSON, and so on and so forth. Here on the right, we have two examples of the same fatal event for a file system full condition. So depending on what you're using as your client or your end logging structure, we can have the ability to consume it easily within whatever service you're using. There's a few more examples of grouping with this standard format. So as we see, we have the when, we have the PID, we have the level, the event, and then the text. In this example, we have the logging being consumed by Splunk and then accessible to all searching and trending and data munging. You'd really want to come with such a tool like that, such as Splunk and others. So as you get these things, you can do all kind of really cool stuff with your log files. And again, there's a whole session devoted just to this. So again, it's only wanted to mention it as a highlight and things that are coming. Any questions on structured logging?
Is this, I missed the beginning, is this just IRIS or IRIS for Health, or is this in HealthShare as well?
The question is this for IRIS and IRIS for Health or also HealthShare? So this is, yes. So IRIS is actually being, or I should say HealthShare is being ported right now to HealthShare, which I believe, don't quote me on this, but I believe it's by the end of the year, HealthShare will be available on IRIS, and then you'll get benefits of this. Non-root container. We now introduce this thing called the IRIS owner. We're currently, in the past, when running an IRIS container, it was owned by root. Security people hated that. Some platforms won't even let you run, like Red Hat's OpenShift. They won't even allow you to start that container because it's owned by root. That's now gone. So starting with 19.3, the non-root container is introduced and having a dedicated user ID called the IRIS owner. And now it owns all the system processes and daemons, which previously were owned by root. So you can see now that with the IPCS command, from within the container, we see the shared memory segments are now owned by IRIS owner. Same thing if we also do a quick PS output and look at all the system daemons, the control daemon, write daemon, journal daemon, and so forth. They're all now owned by IRIS owner instead of root. As I mentioned, this is better security compliance, certainly easing security auditors' heartburn, and getting into a position to allow for, as I mentioned, the OpenShift deployments, where it absolutely does not allow root in a running container. Something to note on this: when upgrading your IRIS container from a prior version is not supported prior to 19.3. So if you have a 19.1 or a 19.2 container, unfortunately, because there's numerous file conflicts, file permission conflicts, you can't upgrade that version. You need to deploy a new container and associate your database files that are on external storage to this new instance. But going forward beyond 19.3, no problem. So just a little pain and heartburn right now to get over that, but it was a necessary evil at this point. The question is, can we customize or change the, yes, but not easily. They'll go over that a little bit more because I believe this is also another session. The next item we have is the new system and alerting and monitoring solution. We lovingly call it SAM. This one's really near and dear to me. Just a brief overview of SAM and how it's come to be, or better yet, how enterprise monitoring itself has evolved. We recognize the need for a new approach. In the past, InterSystems products have always been call it a stack in a box. IRIS will provide you with all you need to build your application from client to server and everything in between. The resulting monolith excelled at providing an environment with known characteristics and major capabilities. However, with the rapid pace of technological change, it become increasingly difficult to incorporate new customer requirements into the product within reasonable timeframes. With the plethora of open source products available for the taking, customers have been faced with the choice of betting on InterSystems technology and accepting scalability and performance, albeit at a slower pace of change, or risking the incorporation into their environment of products from dubious sources with unknown or maybe no support or maybe limited longevity. With the implementation of SAM functionality, we decided to take a different approach. Instead of writing something from scratch from the ground up, we would incorporate major components based on open source and then add value by extending the offered functionality by leveraging its unique capabilities with IRIS. In SAM, we chose Prometheus as an open source implementation of a monitoring system and enhance its functionality by extending its APIs and leveraging IRIS as the primary data store. So you asked the question, why Prometheus and why not? Well, the why, one, Prometheus is well-known and widely deployed monitoring system based on a proven technology. Two, its wide variety of plugins is designed to work well with the cloud environment. It's written in Go, which reduces complexity and minimizes dependencies. They're well-known front-end clients. Grafana is a great example. In one of my other sessions I showed, in the Optane memory performance session, I showed an example of running our benchmarks and using Grafana as the front end. Really slick UI on Grafana, and does all kind of cool things. And it was actually the second project to graduate from CNCF, or the Cloud Native Computing Foundation. It was only second behind Kubernetes itself. So it's very, very mature and a great direction forward. So then why not? Well, and where IRIS fills the gap to add value. So Prometheus doesn't offer authentication or user management. IRIS does. Its embedded time series database can't effectively be scaled. IRIS does. It doesn't provide for high availability. IRIS does. It doesn't deal well with textual metrics, for example, alerts. IRIS does. Its configuration can be complex. IRIS is not. Any questions as to the why and why nots of Prometheus? Okay, cool. So if we look at the SAM approach itself, SAM continues or combines the best of both Prometheus and IRIS to implement an effective monitoring solution which can be highly available, scaled to accommodate enterprise environments. And here's how. SAM consists of three components: the user front end, the metrics and alerts aggregator, and the collection system. We'll examine each, starting with the collection of metric data. In Prometheus, the collection of metrics is called scraping by using a list of targets or machines identified by IP address and port combination. These targets are polled by Prometheus, which makes REST requests to the endpoints of these names exporters on each node. The exporter is essentially just a mini web server which knows how to collect the metrics, for example, OS metrics. And there's tons of third-party options available. returning them in eye-readable textual formats. There's many that are pre-existing and can be downloaded from the Prometheus website. Clearly, IRIS, to participate in the scheme, needs to be implemented and then installed with a separate binary which implements the collector, which is the traditional Prometheus approach. We've actually implemented the collector directly in IRIS as a pre-installed web application based on IRIS. All that is required to enable IRIS instance to participate in a Prometheus scrape target is to enable the web application and assign a password to the SAM user provided for this purpose of scraping. The IRIS Prometheus collector leverages pre-existing metrics collection functionality within IRIS and provides an extension where users can add their own metric collection facility by using subclassing and registering an additional metrics collector class. Alerts gathering. IRIS not only generates metric based on scalar value, but also raises textual alerts. However, Prometheus isn't really optimized for scale. Prometheus is optimized for scalar values, and the authors of Prometheus warns against trying to shoehorn textual logs into its database. So then we asked ourselves, how then are the needed alerts generated by IRIS managed within SAM? The answer is simple. It just means signaling to SAM that one or more alerts have been raised and that SAM, as opposed to Prometheus, should scrape the alerts. So moving on to the SAM operation. So the metrics and alerts aggregator, which refer to simply as SAM, consists of three components: IRIS, Prometheus, and the InterSystems Prometheus adapter, which we named IPA, which now sounds like a really good idea. As noted earlier, Prometheus is configured with a list of targets to scrape and will perform the scraping on a regular time interval, typically 10, 12 seconds or thereabout. The scraping data is inserted into Prometheus's time series or TS database, where requests from the metrics and alert data can be answered by queries over REST. SAM implements its own REST API, which provides for both command and control of the SAM product, but also permits a pass-through from Prometheus-specific query APIs. The pass-through enables third-party products such as Grafana to be configured to query SAM, thinking that they're talking directly to Prometheus itself. This certainly offers up a frictionless integration, a state-of-the-art front end such as Grafana with SAM, while at the same time adding value by securing those APIs, which previously weren't, with CSP authentication mechanisms, something which Prometheus itself does not provide. The limited capabilities of Prometheus's TS database are mitigated by the presence of the IPA or our Prometheus adapter. We've authored the adapter, which enables the data collected by Prometheus to scrapes to be stored into and queried from IRIS, where it can be scaled, mirrored, made highly available, and even more value to the mix. In addition to collecting metrics, Prometheus provides a functional query language called PromQL, or Prometheus Query Language, that lets the user select and aggregate time series data in real time. So getting into the alerting a little bit, Prometheus applies a set of rules which are evaluated on a regular and configurable basis. SAM adds value by making the configuration of rules available by a simple REST API. A collection of rules and appropriate values pertaining to IRIS metrics are also pre-configured in SAM. The alerts are inserted into IRIS and managed by IRIS, so these can be queried independently by the front end. Crucially, this is the mechanism that notices the availability of textual alerts from the individual target and causes SAM to make an additional request to fetch the textual alert from the target in question. In this manner, both alerts raised by the evaluation of Prometheus rules and alerts raised by IRIS can then be incorporated into the IRIS database, effectively aggregating both alerts related to scalar values and alerts based on text, something which Prometheus cannot do, at least not do alone. SAM provides a simple REST API to fetch alerts, which should be pulled regularly to give timely notifications. And then lastly of the SAM approach is the front end. So SAM provides a simple REST API, it's secured by CSP authentication mechanisms, provides the ability to query the metrics, values, and the alerts. Scrape targets can be configured, and targets can be placed into groups for easy selection and viewing. So if you have, say, a sharded cluster, mirrors, or even in health share, once health share becomes IRIS ported, you can put your entire health share federation into a group where you have your access gateways, or you want to group them separately where you say, I want my access gateways in one group, I want my edge gateways in another group. So there's a lot of different ways you can group this data. We do plan to provide our own implementation of a front end for metrics and alert display, but this is in the very early stages of development. But we will have our own UI as well. But again, it's extensible that you don't have to use it. So if you're already using something like Grafana or some other tool that will work with Prometheus data types, have at it. So SAM adds value by making the configuration of rules available as simple REST API. The collection of rules and appropriate values pertaining to IRIS are pre-configured in the SAM installation and may be adjusted as necessary. SAM hooks into this architecture by implementing the REST API where alerts notifications are pushed. Alerts received are inserted into the IRIS database, and again, it can be queried independently from any front end. So here's a graphical representation of what SAM design is. It's showing on the left the client side being InterSystems own provided UI or using some open source tool, again, such as Grafana. In the middle is the SAM Manager, which is a container-based solution that couples together Prometheus and InterSystems IRIS together. And on the right are any number of target nodes that are to be scraped within from Prometheus. Any questions on this? I know I said a lot of words. It's late in the day. Any questions on SAM itself? Okay, cool. So here's an example screenshot again using SAM and a Grafana front end during a recent TrackCare benchmark. If you'd like to see it in action, you can certainly come see me at the Tech Exchange. I'd certainly show you this to you in real time. We can fire up any number of benchmarks and see what it looks like. Hopefully you can see the example here. But basically it's the collection of both OS metrics. So here we have CPU utilization. Then we also have IRIS statistics with global references, journal writes, database reads, CSP sessions, global updates, cache efficiency, so on and so forth. And these tiles or panes can be configured to display anything. So all the metrics that are available within IRIS system.monitor are available through here. So you can get tons and tons of information from this. So just a little bit of a roadmap. So SAM is targeted for 2020.1. And we started with the open architecture. We want it to be composable, open, and leverageable so it can be plugged in with any of your tools or even a new SaaS service option. We developed some REST endpoint enhancements, but by and large, we've leveraged, as I mentioned earlier, what's already available in the sys.monitor sensors collectors framework that's in IRIS and even in Cache today. We're going to be adding an Angular UI where you can register the members of your IRIS node, a sharded cluster, or even a federation of IRIS instances. Any number of instances, really. However, although there's out-of-box default messaging, needles and dials, we let you be extravagant as you want and unleash you out on Grafana or any other tool for more specific and detailed metric operations. So the solution is very robust when combining IRIS with Prometheus. As I mentioned, Prometheus does not have HA support out of the box. And why that's important is when you start monitoring IRIS clusters or your production environment, you grow accustomed to see these metrics in the trend lines, either for capacity planning, historical trending, forecasting capacity. You start to depend on these over time, and that you notice that you can't really live without it anymore because it becomes part of your operation and your daily routine. So the day that monitoring system goes down, and that's when you start questioning, how's my cluster? Is my cluster even running at that point? Sure, there's a lot of indications otherwise, and pagers going off like crazy should that be the case. But when you start realizing and planning for proactive monitoring and proactive capacity planning, adding in your own application metrics, you start seeing the growth of your environment and how you can plan for it proactively. Even in a cloud environment, this is great because, there's other products out there that you can pay for that will do CloudWatch and cloud spend analysis. You can do this all on your own, where you can say, well, geez, I'm over-provisioned my instances. I'm not using more than 40% of my CPU. I'm going to drop down my instance type to go from an R5 4 extra large instance type to an R5 extra large instance type, whatever. So you can help with your resource spend as well. So next year, as part of the roadmap, there are many improvements, ideas that we have and that we just need to execute on. Here's a list of some of the items, including IRIS interoperability with production queues, SQL execution performance, application logs and sensors, and so on. And then beyond that, IRIS is now that fully observable in the coming months and year in a standard open way. SAM then keeps track of the whole cluster telemetry. You'll hear that buzzword a lot. I want to monitor the entire telemetry. SAM's going to offer you that capability. A monitoring system must be an integral part of any InterSystems IRIS-based solution so that we can eventually offer augmented intelligent management or heading to a full self-healing computing. So you'll see that a lot, and a lot of technology and hardware providers do that today, where they do predictive analysis in AI and ML based off of logs and historical data. That's our goal, getting beyond here. So in summary, we talked about a lot of topics today. I know I spent a lot of time on SAM itself, but just a quick recap. So we discussed the various cloud deployment strategies of native, open, and marketplace, provided some examples of the JSON, defaults.json and definitions.json files for ICM deployed on a 4-node cluster. We talked about the new declarative system configuration file, or the CSF, to aid in automation and also configuration compliance or standards. We talked about structured logging and to provide support for leveraging consolidated tools, like Splunk, for example. We went into the new root, non-root container, starting with 19.3. And I dove, again, maybe a little too deep, into SAM and the integration of IRIS with Prometheus. Any questions on that? So here, as I mentioned at the beginning, here's a snippet of all the sessions dealing with cloud and all the various cloud deep dive discussions. We got Kubernetes, Cloud Manager, containers, resilient deployments in cloud, auto-scaling, durable data storage within containers. So there's a lot of deep dive discussions, and I hope I covered as a good general overview of where we're heading with cloud. These containers is a big part of it. So any questions? If not, I think it's beer o'clock, right? So with that, thank you very much.